just wanted to give you all a little bit of a quick intro to the microcontroller that you'll all be using. This is a Arduino Nano ESP32. It's a microcontroller similar to an Arduino Uno or a Nano. The difference is that it's got a different processor on there that gives it some extra abilities, most notably Wi-Fi and Bluetooth. And it's got a couple other sort of like nice things to go along with it. So just wanted to take this opportunity to walk you through a little bit of like what this board is, why you were using it, what you can get out of it. The Arduino itself is an open source project, been around for, it's almost 20 years. Yeah, 20 years now. And there have been a whole bunch of variations on the board that have been built over the years. The Nano describes the form factor here, so this is something that will slot nicely into a breadboard. There are many different kinds of Nanos out there, but this one in particular is interesting because it's using this processor right here, which is called an ESP32S3. So this has both the microprocessor, the thing that runs all the instructions on the chip, as well as the Wi-Fi modem and Bluetooth modem inside of this block right here. Some of the other things on this board, this is the memory, this is a voltage regulator, here's your reset button, here's USB for programming and power. Here's a nice little built-in RGB LED, power indicator, and then another built-in LED that is standard on Arduino Nanos. You'll also notice that there are these pins that go into the breadboard. These are largely called general purpose input-output boards, or GIPO, or GPIO, right? And so these are configurable, and they allow you to determine what what the pin is going to be doing. Is it going to be an input? That is, it's going to be reading information about the world through a button, through a photocell, through a pressure sensor, or is it going to be writing out voltage? So changing the brightness of an LED, or sending pulses to move a servo motor, or sending out sound or data to connect to another device. These are all configurable, and that's something that you do in software. We'll get into that later on. I want to talk at a really sort of like high level about what you should be aware of, in particular if you are coming from a different version of the Arduino, particularly like a Nano, right? So the pins on an ESP32, there's actually like many of them, and so they are mapped to the Nano standard. So when you're writing software on the Arduino IDE, you don't need to do anything silly. You can address pins the way that you typically would by saying like, pin 2, pin 3, pin 4, or A0, A1, A2. But you also have the opportunity, if you're familiar with an ESP, programming ESP directly, you can use the ESP32 pins, which, you've got the opportunity to do that with inside of the IDE. But usually it's like easier to just use the Arduino pin numbers. When you first turn this on, you should see something like this, where the red, green, blue LED is blinking, the power light is on, and then this little amber one is blinking. This is just to signify that it is doing what it's supposed to be doing. You'll only see this the very first time you plug it in out of the box. You can reprogram this exact same code on there if you want, but it's just a nice indicator. One other thing to note about this as far as programming goes, well, we will primarily be using or exclusively be using the Arduino IDE for this, and writing in the Arduino language, which is variation on like C and C++. You can also write in code for this board in something called MicroPython, which is an implementation of Python that is designed for microcontrollers. It's pretty nice because unlike the Arduino IDE, you don't need to compile it. You can just write your code and drag and drop it in here. Not something I'm going to cover, but it is something for you to consider if Python is something you're really familiar with and you want to experiment with it. The board is designed to not draw a lot of power. And so in the spirit of that, it runs off of 3.3 volts. So all of these pins here are 3.3 volts. USB provides 5 volts. So that means that you are powering it from a different voltage than what you would actively be like reading sensors and things off of on here. So do not use the VIN pin or the VBus pin for powering sensors unless you ask somebody first. Don't just ask Reddit or look up a YouTube video. And for the love of everything that is good in the universe, do not just ask a large language model what to do, because all of these things will probably lead you astray and wind up burning out the microcontroller. It is only 3.3 volt tolerant, so you want to power everything off of the 3.3 volt pin right here, unless your instructor or somebody else who you know personally has instructed you to do so otherwise. There are a number of different things that you can do with this to make it even more, more tolerant to, or more sort of draw less power. You can have it only work off of 3.3 volts. You can have it go into sleep or low power modes. A whole bunch of different things that you can do with that. Generally, though, you're going to be powering things off of the USB. That'll get you 90% of the way there. And these pins are fairly standardized across Arduino boards. So you've got, on this side, you've got ground. Those are indicated by the ones with the white stripe. You've got transmit and receive for hardware serial communication. You've got a reset button, which you can use to reset from an external component as opposed to pressing this button right here. Then you've got a row of digital input or outputs, and you've got another one over here. This pin 13 is tied to this LED right here, so if you say pin 13, you'll turn on that LED. It's just something to be aware of. So generally the digital inputs are these right here, pins 2 through 12. Any of these pins can be used for analog output, so that is PWM. So if you want to fade, an LED, that is how you would do it. You can only have 5 PWM cycles going on at any given point in time, which is just something to keep in mind. You probably won't run into any issues with that, but just something to think about. On the other side here, we've got our 3.3 volts. This B right here and this B right here. These are these are boot pins, right? So don't worry about that. You don't ever need to really concern yourself with them. The ones that you will worry about on that side, though, are these ones that are A0 through A7. Those are your analog input pins. So that's where you would read sensors from, say, a potentiometer or a photocell or a temperature sensor that spits out an analog voltage. If you are using something like I2C that's on pins A4 and A5. If you're using something like SPI, that's on digital pins 13, 12, and 11. So you'll have to look and see and check on those values. But all that communication is there and available to you. There are multiple I2C and SPI ports. There's also multiple serial ports. There's both this one, and then there's serial. So that's just serial. This is serial 0. Serial 1 and 2 can be assigned to any of these pins. So you can have multiple different communication methods going on simultaneously. And in that spirit, on the USB, you can also emulate an HI device so that you can have this show up as a mouse or a keyboard, which is a really nice trick for getting information into a computer. There's a whole bunch of other functionality that gets more complex, but this is the basic stuff that you'll deal with in the first few weeks of using this. Inputs, outputs, nothing fancy like that. Other courses that you get into might deal with the Wi-Fi or Bluetooth or some of the other functionality in here. But you can do a lot without having to, get too complicated with this. So this is, again, a really high-level overview of this board. We'll get into additional topics with this in subsequent videos. But hopefully you have a better understanding of what this is and what it is capable of.